Hey there. We've already done day one, but I'm going to go ahead and do them again and just run through the notes real quick. All right, we talked about how water is a unique compound, how to draw the Lewis structure. Remember, it looks like Mickey Mouse ears. Um, it's polar because it has a lot of electronegativity on the oxygen end because the oxygen's negative. The hydrogen end is positive because the electronegativity differences, or the electronegativity is lower than that of oxygen. Water's bent, water's polar. There's really strong hydrogen bonds between the polar molecules of water. And that is what explains these high boiling point, vaporization, or high heat of vaporization, high surface tension, those things that we talked about in class. We talked about how the density of water is different when it's a solid rather than when it's a liquid. It tends to be more dense at that 4-degree temperature and not so dense as it turns into a solid, if you notice up here. Talked about hydrogen bonds, aqueous solutions. An aqueous solution is something that's dissolved in water. Now, solids, liquids, and gases can all be dissolved in water, so they can all be aqueous substances. A solution has two parts, the solvent and the solute. The solvent's what's present in the larger amount, and the solute is what's present in the smaller amount. So when you dissolve sugar into water, sugar would be the solute and the solvent would be water. Solvation is how solute dissolves. It's surrounded by water molecules, and it is how things dissolve. The prediction of whether solubility will occur, we tell you like dissolves like. So what that means is it's more likely for water to dissolve a polar compound than a nonpolar compound. In order to dissolve something that's nonpolar, it would have to have a nonpolar solvent. So like things will dissolve other like things. If the solute, we're talking about solutes here, if the solute is ionic, it tends to be soluble. Remember, we have to check those solubility rules because not everything that's ionic is soluble, which we found that out, unfortunately. Not everything dissolves in water as we thought it would. But ionic compounds, if they're soluble, they tend to form really good electrolytes, and electrolytes are compounds that conduct electricity when they're dissolved in water or when they're in the molten state. A polar covalent compound, if you draw the compounds, a polar covalent compound is a covalent compound that the structure would be polar. And remember how to tell if something's polar. It would have lone pair on the center atom, or it may have different things bonded to the center atom. So if it's a polar covalent compound, it will tend to be soluble in water, but it still won't form an electrolyte because electrolytes are specific to these ionic compounds. Ionic compounds will break apart into ions, into charged particles. That's what makes an electrolyte. So polar compounds, while they may dissolve in water, they don't break apart in water like an ionic compound does. So they won't be an electrolyte. Nonpolar covalent compounds are those structures when you draw the Lewis structure of a covalent compound. The nonpolar covalent compound will have an equal distribution of electrons. There won't be a lone pair on the center atom, and there won't be different things bonded to the center atom. Those things tend to be insoluble, and they tend to be non-electrolytes. They won't conduct electricity in solution. Strong and weak electrolytes. Strong electrolyte produces a lot of free-moving aqueous ions. So that means when it breaks apart, every bit of it breaks apart, not just a little bit. Things that would make a weak electrolyte are things that would produce small quantities of ions. So only a few of the little ionic compounds will break apart rather than all of them. Here we have a picture of different things in dissolved and whether or not they're conducting electricity. So up here, the bulb is not lit at all. So what that means is ethanol is a nonpolar covalent compound. It won't conduct electricity at all. Here you have something like potassium chloride that forms a really good electrolyte and will break up a lot, will break up completely in water, and it'll have a lot of charged potassium ions and a lot of charged chlorine ions. And those ions will be able to carry charges back and forth and conduct electricity really well. Here we have something that would be a weak electrolyte, so something like acetic acid, and I give you guys that example because it's a good example. Acetic acid, while it's an electrolyte, it will break apart in water. It won't break apart very much. Only very few hydrogen ions will break apart from the acetate ion in acetic acid, so it forms a weak electrolyte. We'd given you examples, or I gave you an example of strong electrolytes. Something like table salt is a strong electrolyte, or nitric acid. An example of a weak electrolyte would be that acetic acid that I had talked about. Strong acids will dissociate 100%. They'll dissociate completely. For like hydrochloric acid, it completely dissociates 100%. Something that's a weak acid, like acetic acid, this acetic acid will only break apart a little bit. Maybe 1 to 5% of the hydrogen ions will come apart from the acetate ions in solution. So while they'll form an electrolyte, it'll be a super weak electrolyte. So what is solubility? Solubility is the number of grams of solute that dissolves in a given quantity of solvent at a given temperature. Factors, things that affect solubility. Now this means how much of the solute will dissolve. Temperature has a great effect on whether or not, or how much something will dissolve. So usually, generally speaking, if the temperature is higher, more will dissolve. So I can dissolve more sugar in hot tea than cold tea. But gases are the opposite. In order for gases to stay dissolved, the temperature has to be cold. The temperature of the solution has to be cold. So gases just do the opposite. The nature of solute and solvent. Most ionic and polar covalent compounds will dissolve in water. Most. Remember, you have to check your solubility rules. Nonpolar covalent compounds won't dissolve in water. So the nature of solute and solvent has to do with, or will tell you whether or not something will dissolve. This is a good flow chart if you're having trouble still determining whether or not something is ionic or covalent. So first thing you do, you look at the formula. Does it have a metal in it? Well, if it has a metal in it, then it's an ionic compound. Most ionic compounds are soluble, but you have to look at your solubility rules because there are ionic compounds that aren't insoluble in water. So if there's not a metal in the formula, then it's a covalent compound and you get to draw the Lewis structure. Now I say you get to draw it because I think that's one of the more fun things that we get to do. So you draw the Lewis structure. When you draw it, you determine if it's polar or not. If it's polar, then yes, it will dissolve in water. If it's nonpolar, it will not dissolve in water. And pressure. Pressure also determines whether or not something will dissolve, but that's only for gases. It's not for solids. It's only a factor for gases. As pressure increases, the solubility of a gas increases. So if we keep the lid here on the soda bottle, the carbon dioxide will stay dissolved in solution. But once we pop that top, the carbon dioxide starts to come out of solution and the bubbles leave and you get a flat soda. Now, there are factors that affect the rate or how fast something will dissolve. If you stir something up, it will provide more contact with the solute. So if I'm trying to dissolve sugar in my tea and I stir it, I'm going to put more of the sugar particles in contact with the tea particles, and we're able to get it to dissolve faster. So temperature also affects how fast something dissolves. If the temperature is higher, then there's going to be greater kinetic energy, so there's a lot more collisions between those particles, and the solution will, or the solute will dissolve faster. Particle size also, finer particles, small particles, have more surface area exposed. So greater exposure to the surface area, that solvent's able to work on the solute a little bit better and dissolve it faster. So remember, heat it, crush it, or stir it up. If something is miscible, these are just two new vocabulary terms. If something is miscible, that means that it's two liquids that dissolve in one another. If something is immiscible, those two liquids wouldn't be soluble in one another. They wouldn't dissolve in one another. Here we've got examples. Things that are miscible are water and alcohol. Those two things will dissolve in one another, but water and oil, as you know, will not dissolve in one another. These are more S words for this porous solutions unit. As the temperature increases, you can dissolve more and more solute except for gases. A saturated solution is one that has the maximum amount of solute that can possibly be dissolved for that temperature. An unsaturated solution means I could dissolve more if I wanted to. Let's say if I can dissolve 3 teaspoons of sugar and make a saturated solution, if I only put 1 teaspoon of sugar in there, well, yeah, it will dissolve in there, and I could put more, so that means it's an unsaturated solution. A supersaturated solution is one that contains more than it would normally contain at that temperature. So if I wanted to dissolve 5 teaspoons of sugar in that tea, I would need to heat it up, dissolve the 5 teaspoons of sugar, then cool it back off to try to make that supersaturated solution. Okay, we're going to stop here. We'll go to day 2 next, and I hope you enjoyed.